Welcome students, and today we are on lesson 3 and we're going to talk about perimeter and circumference. Now the word perimeter comes from the Greek prefix peri, which means around, and the Greek word metron, which means measurement. You don't have to memorize that, just a little side note. So perimeter means the distance around or the measurement around something. Circumference, on the other hand, it's the perimeter of a circle, basically, the distance around a circle, but we have to use a calculation to get the circumference, so we give it a special name and we call it circumference. And that's the word that you get for, circumnavigating the globe. That means they're navigating around the globe. So the distance around a circle is circumference. Now, in order to calculate the circumference of a circle, we have to use a special, what's the word I want to use? We have a symbol for it, but it's a special value, and we call it pi. And we use this symbol here, which is the Greek letter pi, P, for this numerical value, 3.14. Now, 3.14 is not it's the absolute value. It is not the absolute value, it's not the exact value of pi. Pi is a decimal that goes on and on and on forever. It is a non-terminating, non-repeating decimal. So we have agreed as mathematicians to just use 2 of those decimal places for the sake of succinctness and being able to calculate, and not everybody picking whichever decimal value they wanted to use, and we all end up with different answers. So the mathematical world has agreed to use 3.14 in order to calculate the circumference of a circle. I will add that when you're doing some of our later mathematics in Algebra 1 and we get to a point where we're using complex formulas, it's actually more exact to just stop at the symbol pi and not multiply it times 3.14. It's a much more, it's the most exact value you can have for a circumference. Is just to stop at the pi symbol as a variable instead of calculating it. Anyway, I gave you a little added bonus here. If you want to type the symbol pi while you're doing your schoolwork, or you're doing, for whatever reason, on your keyboard, if you have a Windows keyboard, you're going to press the Alt key and the P button. So press on your Alt key and press P, and when you can try this in Word or some other typing scenario, even in Google, you could type P. I think it'll let you do it anyway. Or if you're on a Mac, you press down the Option and then you press the P and release, and you will get this pi symbol. Now, I know when you're on Jupyter Ed and you're typing in your answers, this is a shortcut you can use. You don't have to pull up the digital keyboard that is available, but it is available on the Algebra digital keyboard within Jupyter Ed. So you don't have to memorize this, but if you do, and the only symbol you need is a pi symbol to do your answer, this is a shortcut. So you can write this down. Everything here in this little cloud, you need to put in your notebook, okay? Write these definitions. Now, the other thing that you're going to need to put in your notebook is the formula for circumference, and we'll get to that in just a moment. First of all, let's do the perimeter. This is example 3.1. Now, this is how you would typically do the perimeter of a polygon. You're going to be given a polygon shape, and you're going to be given some dimensions for it. And then you are going to be asked to, hold on, I got these backwards. This one is 3, and this one is 4. And this one is 15, and that's all the dimensions we're given, okay? You're going to be given a polygon, and you're going to be given some dimensions, and there's going to be some dimensions that are left out to make it a little bit harder. Now, in pre-algebra, you were probably given all of the dimensions, and that's fine. But in Algebra 1, we're going to ask you to think a little bit and think about the shape, and we're going to ask you to apply some geometry skills and to recognize how to find those missing dimensions. So in this case, let's go ahead and start. We need this dimension, and we need this dimension right here. We don't know what those are. So we can get this one pretty easy. We know that this and this should be the same measurement because these corners are square and these lines are parallel. So this is 9. We know it's the same as this one, okay? This one's a little bit harder. Now we know that from here to here to here, all added together, should be the same as this here because all of our lines, our corners are square and our lines are parallel. So 3 and 4 is 7, right? So 7 from 15 should be this measurement here. So 15 minus 7 is 8. Right. Now there are two ways that you can find this perimeter, and I guess finding those missing measurements is part of the first way. If you do it the second way, you don't have to find the missing measurements. It's a little bit easier, a little bit faster in that regard. So we had to find the missing measurements, and now we're going to have to add all the lengths up together. So the thing to do is pick a starting point or pick a measurement of where you're going to start. And I like to start with the smallest number first, just because it's the way my brain works. So you're just going to make a list. You're just going to go, you're going to start here, and what I do is I circle them. Excuse me. I swallowed wrong and made myself cough. So I start with 3, and you write your 3 down. And then you go to 9, and then 15, and then 9 again, and then 4, and then 5, and then 8, and then 5. And if you do it like that, you have circled everything. You know, you've included all your measurements. You haven't written anything down twice. Using an indicator to show that you have included that measurement will keep you from making some type of mistake, either from leaving something out or from writing it down twice. So that's just a tip that I would use, or something that you could do to help you do that a little bit better. If we added all those together on a calculator, that would equal 58. Okay? There's a faster way. And that faster way means that you don't have to find the missing measurements. You just know, because the corners are square and the lines are parallel, that you have two ends here, a left and a right, and they're both 9. So you would say 2 times 9. And you would know that this and this and this equals this. So you don't have to do the math. You just say 2 times 15. Okay? Now when you're doing this, you want to put some kind of indicator on the line. You got those. And with the 2 times 15, you got these, right? Now you need to get this one and this one. So that's 2 times 5. So you got this side and you got this side. All right, so doing that is just another way, but always use some type of indicator to make sure you've included all your dimensions. Now if you do this, you get 18, you get 30, and you get 10. And those added together are still 58. So it's the same measurement. It's just a little bit faster. But if your brain works such that you have to do each side individually, do each side individually. If your brain can take the leap to do it as a top and a bottom and a left and a right and include those extra little legs that were added for the dip, then do that. It's up to you whichever way you want to do it. As long as you get the right answer, the same answer, I don't care. I'm not going to force you to pick something you're not comfortable doing, as long as it is still a right way to get the right answer. Okay? So now let's talk about circumference. Circumference, the distance around a circle. There's a special formula for circumference to figure it out. And a long time ago, somebody way smarter than me, way smarter, decided or determined through a lot of mathematical trials that there's a ratio for the radius of a circle to its circumference. And that is what resulted in the formula for circumference. 2 times pi, pi is the ratio, and times the radius. Okay. Now we know that 2 times the radius is the diameter. So there's a second formula. If you have the diameter, you can just say diameter times pi, right? Because 2 times the radius is pi. And let me illustrate that. If we have a circle here, right? and that has a radius. Here's the center of the circle. The radius is just the measurement from the center of circle to the edge. So let me write that out for you. Actually, it's probably better if I type it because my handwriting is not great on this tablet. So let me type that for you. The radius, if I can spell today, is the distance from the center of the circle to the edge. And the diameter is the distance across the widest point of the circle. And it, cuts the circle exactly in half. It also happens to be 2 times the radius. Okay, let me spell that a little bit. 2 times the radius. And that equals the diameter. So now that we know that, you want to write this down as well. And you don't have to write down all of this, but do write down that the diameter is 2 times the radius. Okay? And all a diameter is, this is the radius, the diameter is just this. So when 2 of the radius line up, they go across the widest point of the circle, which is going to be the diameter because you have 2 times a radius, right? Radius plus a radius. So do write down all of this for sure, as much of this as you want, but this for sure as well. Okay? And that is illustrated in our circumference formula, 2 times pi times r, which we know because the commutative property of mathematics that you should have learned about, oh goodness, in elementary, that you can rearrange these factors to multiply in any order you want. So 2 times r times pi, 2 times r is this down here, which is the same thing as the diameter times pi. Okay, so let's do a couple of example problems. Let me add another page here. And let's scroll back first. Okay, if you have not written all of this down, pause now and take all of your notes. And then I'm going to scroll on immediately and do the next 2 example problems. So pause if you need to. I'm scrolling now. All right, so example 3.2, okay? In this example problem, let me get a thicker pen. We have a radius of a circle that equals 3 centimeters. What is the circumference? So what does the circumference equal? So what we're going to do is we're going to drop in our formula. And that's the other thing that you need to write down. I'm sorry, let me go back. Whenever I give you a formula, you need to write that down too. So if you didn't write that down, write that in your notes as well. Also, put this on the back cover. Told you my handwriting is terrible with this pen. On the back cover of your spiral. If you do that, then you will have it for easy reference during a quiz. During a quiz, if you're in my classroom, I will let you look at the back of your notebook, but you cannot open it. Okay? So put your formulas on the back cover of your spiral notebook that you are taking notes in. All right, let's go back to 3.2. So we know the formula, so let's drop it in here. We have C equals, this is a radius, so we need to use 2 pi r, right? And then we'll drop in our radius measurement. So C equals 2 pi and 3, right? 3 meters. So that's going to be 2 times 3. So C equals 6 pi meters, right? And the unit of measure is always at the end. So now we need to do 6 pi. So C equals 6, and we know pi, we're going to use 3.14 meters, right? So once we do that calculation on our calculator, we come up with 18.84 meters is our answer. Okay, so that is how you solve for a circumference using this formula that we already discussed. Once you get to this point right here where you've done 2 times the radius, this is diameter pi. You could easily do in your head 2 times 3. When it's a small number like this, you could say, okay, well the diameter is going to be 6, and just start here. That's up to you. You get the right answer, and I know I can see you've done the work. I'm not going to complain, and I'm going to just mark it right and move on. So let's do another one. This one, example 3.3, it's a little bit different because we are given the circumference and asked to find the radius. So the circumference is equal to 24 meters, right? So now we have to back it out. So we know 24 meters, and we're going to put in the formula. We have 2, and we know that pi is 3.14, but we don't know the radius. So we leave r there. So now let's go ahead and do what we can do here, which is to multiply 2 times pi. So 24 meters equals 2 times that's going to be 6.28 times the radius. So if we divide both sides by 6.28, which is how you separate factors, you divide, you do the opposite or the inverse operation. But you have to do the same thing to both sides because it's an equation. You have to keep both sides equal. So 24 divided by 6.28 is going to be 3.82 to 2 meters. These two cancel, and that's your radius. So we bring radius down here. So 3.82 meters is the radius of a 24 meter circle. Okay? All right, so let's move on to example 3.4. It's a little bit more complicated. All right. Now in 3.4, we are told that we need to find the circumference or the perimeter of this figure. When you have a half circle here attached to this polygon, they're going to say perimeter. They're not going to say circumference because perimeter and circumference mean the same thing, but a circumference is only in relation to a circle by itself. Okay. So when they say perimeter, they mean all of it. They mean include the circle. The dimensions are in inches, and our dimensions are a radius of 3, and this side here is a 10. And that's all we're given. So we have to figure out the rest. So because we are told everything is square, everything is parallel and perpendicular, we can safely assume that from here to here, this is the diameter of this half circle because it's 2 radius long. We have a radius here and a radius here, and 3, this is 3, and this is 3 because this is the center. So that's 6. So we can figure out that this one is 6 over here. And because this cuts off at the same point, we can assume that this is 10, right? So there's that. So 10 and 10 is 20 plus 6. So that's 26 to start with. Now we have to figure out from here all the way around to here. What is that measurement? Well, it's a half circle. So we need to say 2 pi r, but because it's a half circle, we're going to divide it by 2. Okay? So right away, we can go ahead and factor out some things. So we can eliminate the 2 here. We could take, because these are multiplied by each other and this is divided by 2, we can eliminate the factor of 2. So in a half circle, your formula is pi times the radius. Okay, we canceled those out of each other. So we're going to say that it is 3.14 times 3, because 3 is the radius. And 3.14 times 3 is 9.42. And that is in inches. All right. So all we do is we take this half circle and we add it over here to our 26, and we end up with a total of 35.42 inches for our perimeter, and that is the right answer. Oops, didn't want a frowny face, I want a smiley face. There we go. So that's the correct answer. So that's all you have to do when you want the circumference. So that's another thing to write down. Circumference of, I'm just going to shorten that, of a half circle equals pi times r. Okay, so you might want to put that on the back of your notebook as well, because it's a shortened version that you can skip this step here and just go straight here when you have a half circle. So let's do that when we do this one down here. This is 3.5. Right, and we have the dimensions here of, this is a 4 radius, this is 6, this is 5, this is 14. Actually, sorry, we're not given that. We're only given these, and we have to figure out what this is. Okay, so let's see, how did they get 14? Well, we have a radius here of 4. So this is the diameter. The diameter is 2 times the radius, so that's 8 plus 6, that's 14. That's how they got that. And then we don't have this measurement, but we have a radius of 5 here. So that's 5 and 5, that's 10. So the measurement is 10 here. Okay, so now we can add our flat surfaces. So we have 10, mark that one off, 6, mark that side off, and 14. And mark that side off. All right, so I've got those. And that's going to be 30, right? Because 6 and 4 is 10, carry 1, that's 1, 2, 3. All right, that's 30. And the dimension here is in feet. So it's 30 feet to start with. Now we've got to get these 2 half circles. All right, so we have a half circle with a radius of 4. So we know that the half equals pi r, right? So that's going to be 3.14 times 4. And the other half circle has a 5 radius. So that's pi r. And that is 3.14 times 5. So those are our 2 half circles that we have to figure out. Okay, and so this one, when we do the math, ends up being 12.56 feet. And when we multiply these two, we get 15.7 feet. And all we have to do now is add those over here. So 12.56, and that's this one, and 15.7, that's this one. Okay. When we add those all together, we get 58.26 feet. All right, and that is the right answer. Okay, and the way we got there, if you remember, this was all the flat sides, right? The 30. And then this was the half of the 4 radius circle. And this was the half circumference of the 5 radius circle. And we figured those out here. This one was the 4. This one was the half circumference. And this was the 5, right? So the way we figured this out was up here. When we did the circumference of a whole circle is 2 pi r, but it's a half circle, so we divide it by 2. Those cancel out, leaving pi r for the circumference of a half circle. Or you could just say half of a c. Half circumference is pi r. Okay? So write that in your notebook. And you can write it like this if you want. You can write your half the circumference is pi r if you want to put that instead of this long one. That's up to you. All right, that's all we have for the lesson 3 on perimeter and circumference. We will have more for you in lesson 4, and I will see you there.